We're now going to turn our attention to the first of the key capabilities provided by Java built-in monitor objects, and that is synchronized methods. And as we'll see, synchronized methods are provided by Java built-in monitor objects to support mutual exclusion. And we've seen before, mutual exclusion is this means of being able to protect shared mutable state from corruption due to concurrent access by multiple threads. To do this, we're going to use an example called busy synchronized queue. So before, remember, we had buggy queue. This is busy synchronized queue. And it's going to be implemented in a way that will be thread safe, but not necessarily optimally efficient. But at least we'll solve one set of problems before we go on and tackle the whole enchilada. So busy synchronized queue also implements the simple blocking queue interface, just like we saw before. And this interface is a variant of what's available in Java's blocking queue interface, which is what the array blocking queue and link blocking queue implement. Here's the state that's part of the class. This is what needs to be protected against race conditions. And you can see it's a linked list, and it's an int that keeps track of the number of elements that are in the queue. The constructor just initializes the state. Constructors don't need to be synchronized. And the reason for this is that a constructor should only be called once, and it should not be called in a way where it depends on protection against, well, let me rephrase that. If a constructor accesses objects that are shared with other threads, then it would need to be synchronized internally, but you typically don't make the constructor synchronized because it's only intended to be called one time in one thread. So that's what this says. A constructor is only called by a single thread, so synchronization isn't needed unless the implementation of the constructor accesses some shared resource that needs to be protected. And I would not recommend doing that by requiring the constructor to be synchronized. I would recommend doing that by having the objects that it's accessing be synchronized, but that's a slightly different story. This particular discussion here is going to show how methods in a built-in monitor object can be marked with the synchronized keyword. So there's two ways, as you recall, to get synchronized methods. One is to make them synchronized, like we're showing here, and the other is to make synchronized statements inside the method bodies. We're going to talk about that later. So here's the straightforward way you make the method synchronized. As you probably already can figure out, a synchronized method is serialized with respect to other synchronized methods in a particular instance of an object or instance of a class, an object. If you have synchronized methods but two objects, then there's no reason why those two objects can't be accessed concurrently by multiple threads, by two threads. It's only if you have a synchronized method in a single object that it has the effect of ensuring there's only one thing taking place at a time in a critical section, which in this case is the body of the method itself. And as we saw before, you can think of synchronized as basically implementing a Reentrant lock-like mechanism that encompasses the entire body of the method, from the open curly brace to the closed curly brace around the entire method. That's actually not quite how it's implemented. It doesn't use Java Reentrant lock, but conceptually you can think of it like that. When you use synchronized in the method declaration, as we do here, the entire body of the method is serialized. So all the things from the open to the closed curly brace. Interestingly enough, the synchronized keyword is not considered to be part of a method's signature. It's considered to be part of the method declaration, but not its signature. What the heck does that mean? What that means is that synchronization is considered an implementation detail, not an interface property, and therefore the implementation of this, when you if you were to subclass from busy synchronized queue, the subclass that decided to override any of these methods would not, in fact, have synchronized methods. You would have to add synchronization explicitly to subclass methods that overrode these methods if you wanted them to be synchronized also. So the way to think of this is the synchronized keyword is not inherited by subclasses. So that's basically what that says. So if you subclass something, if you have synchronized queue that extends busy synchronized queue, these methods will not be synchronized unless you decide to explicitly mark them as synchronized or use synchronized statements within them. So what are the good things about synchronized methods? Well, one nice thing is by marking them as synchronized, it's pretty darn easy to tell visually that these methods are synchronized, right? It's no mystery. If you see a method that has the keyword synchronized, there should be no shadow of a doubt in your mind that these methods are going to have mutual exclusion properties when they're called by multiple threads on the same object. Another nice thing about synchronized methods is the method is the unit of synchronization. When you invoke a method, that method will be guaranteed to run in a mutually exclusive way on the object for which you're invoking it. So it's a very convenient way of thinking about synchronization boundaries. You know, the method is synchronized. What could be easier to understand than that? And in particular, it's easy to reason about, or easier to reason about method-oriented synchronization, because it's just a very convenient abstraction. We know how to call methods, and by marking them as synchronized, we know how to call methods that will run in a mutually exclusive way when multiple threads call them on the same object. So that's cool. I think it's also worth noting that the syntax is compact. There's no synchronization in the body itself. You just have synchronization here at the boundary of the begin and end parts of the method. Another nice property of synchronized methods, which may not be entirely obvious at first, but it's good to know, and it is consistent with other discussions we've had, they support reentrant mutex semantics. If you remember our discussion earlier from a week or so ago where we talked about reentrant mutex in the context of Java reentrant lock. So here's an example of this. You can see here that we have a method called offer that's synchronized and a method called isFull that's synchronized. And you'll see that offer calls isFull. So offer is synchronized, so it acquires the lock before any of this code is run. It then calls isFull. isFull is synchronized, and therefore it uses recursive mutex implementation semantics to ensure that it just increments a count if the thread that is trying to reacquire the intrinsic lock, which is what you do with synchronized methods, already owns that particular intrinsic lock. It doesn't deadlock on itself, which is good. But of course, not everything is unicorns and rainbows. There are some downsides to synchronized methods. One of the downsides, and this is very subtle, is it synchronizes on the intrinsic lock, which is this. It's part of the this object. So it's possible for other objects to synchronize it with it too. And this is really confusing. So here we've got ourselves a busy synchronized queue, and we have thread T1 while queue is empty. That's a synchronized method call. And then down here, another thread says synchronized queue. Queue is the object. Well, believe it or not, that will actually cause this thread to hang. It'll never get to go inside is empty as long as thread T2 owns that particular intrinsic lock. Very weird property. Another limitation with synchronized methods is it makes the granularity of synchronization rather coarse-grained. Now, I just told you that one of the nice things, one of the pros of synchronized methods was the fact that the method is the unit of synchronization. So that's a pro. But if the method is very long and complicated, that could become a con because that method throughout its entirety holds that intrinsic lock, because synchronization is on a per object / per method basis. So if you have long methods that are synchronized, that can become a bottleneck. Well, needless to say, we're going to show some ways to overcome these problems in the next part of this lesson, which will do a deeper exploration of Java synchronized statements.